Hello friends, I am Nasu Rajkumar and welcome to my channel NRK Mathematics. Today in this video we are going to derive the formula for area of a triangle using the formula for area of a parallelogram. Let's derive the formula for area of a triangle using the formula of area of a parallelogram. Let us take a triangle PQR and drop a perpendicular from P onto QR, which intersects QR at a point E. This perpendicular, which is of h units length, is called the height corresponding to the side QR, which is of b units length. So finally, we have drawn a triangle of base b units and corresponding height h units. Now let's take a copy of this triangle PQR and rotate it by 180 degree and paste it along PR as shown in the figure. In doing so, we get a quadrilateral PQRS, which is a parallelogram. The quadrilateral PQRS is a parallelogram because the opposite pair of sides are equal, as they are the congruent parts of the congruent triangles PQR and PSR. Now let's learn how to convert any given triangle into a parallelogram. How to convert a triangle into a parallelogram of the same base and height. Step 1. Take a copy of the given triangle. Step 2. Rotate it by 180 degree. Step 3. Paste the copy to the original along any one of the congruent sides, and this results in the formation of a parallelogram. The coinciding sides become one of its diagonal. Let us take a triangle and name its three sides as 1, 2 and 3. And let's take a copy of this triangle and rotate it by 180 degree and paste it such that the side congruent to side 1 coincides with the side 1 of the original, and this results in the formation of a parallelogram with side 1 as one of its diagonal. Now let's take another copy of this triangle and rotate it by 180 degree and then paste it such that the side congruent to side 2 coincides with side 2 of the original, and this results in the formation of a parallelogram with side 2 as one of its diagonal. Now let's take another copy of this triangle and repeat the same process, but this time we will paste it along side 3 of the original, and this results in the formation of a parallelogram with side 3 as one of its diagonals. So finally, these are the three different parallelograms which we could make from the given triangle PQR and its copy. We can see that all these parallelograms are made up of same two triangles which are congruent, and hence they must be equal in area. Of course, they look different in size, but the area must be the same as they are made up of the same two triangles which are congruent. So finally, we can say that two equal triangles of base B and corresponding height h add up to form a single parallelogram of the same base and corresponding height. Therefore, we can write area of two equal triangles is equal to area of parallelogram with same base and corresponding height. And we know area of a parallelogram is equal to base into corresponding height. So this implies area of two equal triangles is equal to base into corresponding height of the parallelogram which is formed. And this implies area of one triangle is equal to half the product of the base and corresponding height of the parallelogram formed. And since the base and corresponding height of the triangle as well as the parallelogram are the same, we can write the area of the triangle is equal to half the product of its base and its corresponding height. And for area of a parallelogram, you can check the link given below. So finally what we have got is area of a triangle is equal to half the product of its base and its corresponding height. Now let's learn what we mean by the terms base and corresponding height of a triangle. Actually, any side of a triangle can be called as a base. And by corresponding height, we mean the length of the perpendicular drawn to this side from the opposite vertex. So let's understand these two terms better through a diagram. So ABC is a triangle, and in this we have drawn a perpendicular on BC from A, which is of h1 units. So h1 is the height corresponding to the side BC. Now let's draw another perpendicular from C onto AB. So this is called the height corresponding to side AB, which is of h2 units length. Now let's draw another perpendicular from B onto AC, and this is called the height corresponding to the side AC, and this is of h3 units length. So from this figure it is clear that h1 is the height corresponding to side BC, h2 is the height corresponding to side AB, and h3 is the height corresponding to side AC. As we have already derived that the area of a triangle is equal to half into base into corresponding height, here the area of the triangle ABC can be expressed as half into BC into h1, where h1 is the height corresponding to the side BC. This can also be expressed as half into AB into h2, where h2 is the height corresponding to the side AB, and we can also express the area of this triangle ABC as half into AC into h3, where h3 is the height corresponding to the side AC. So these are the three different ways in which we can express the area of a triangle using the three different bases and their corresponding heights. Therefore, using the formula area of a triangle is equal to half into base into corresponding height, we can get the area of a triangle provided the base and corresponding height are given. Thank you for watching this video, and if you like this video, please don't forget to give a like and share this video.